Hello, I'm an avatar created by Yili Lin, a PhD student in health services research at George Mason University. Let's continue our discussion on interpreting ANOVA results in R. In one-way ANOVA, mean squares, MS, are obtained by dividing sum of squares by their degrees of freedom, reflecting average variability for between-group and within-group differences. Two-way ANOVA calculates mean squares for main effects and their interaction, assessing both individual factor effects and their interactions. Both types share the same within-groups mean square, MSW, which measures unexplained residual or error variance within groups. In one-way ANOVA, the between-groups mean square reflects the variation among group means based on a single factor. In two-way ANOVA, this mean square is divided into components for each factor, revealing the variance explained by each factor individually. The interaction mean square, MSAB, in two-way ANOVA is essential for assessing whether the effect of one factor varies based on the levels of another factor, a test not possible in one-way ANOVA. The mean square for supplement is 205.35, reflecting the average variation between the different supplement levels, while the mean square for residuals is 55.98, representing the average unexplained variation within the groups. Since the mean square for supplement is larger than that for residuals, it indicates greater variation between the supplement groups compared to within the groups. In two-way ANOVA, the mean squares for supplement and dosage are 205.4 and 2224.3, respectively, indicating the average variation due to these factors. The mean square for their interaction is 88.9, reflecting the variation from their combined effect. The larger mean square for dosage suggests that dosage explains significantly more variation in the response variable than either supplement or the residuals. The F statistic in one-way ANOVA compares variance between groups to variance within groups to assess significant differences in group means. An F value of 3.668 for the factor supplement indicates that the variation due to the factor is notably larger than the residual variation. In two-way ANOVA, multiple F statistics assess the effects of two factors and their interaction. The F value for the supplement factor is 12.317, indicating a substantial variation compared to residuals. The dosage factor has a much higher F value of 133.415, signifying a significant impact on the response variable. The interaction effect between supplement and dosage is represented by an F value of 5.333, suggesting some interaction between the two factors. The p-value in one-way and two-way ANOVA both indicates whether a statistically significant difference exists, but its context differs, affecting its interpretation. In a one-way ANOVA, the p-value tests whether any group means differ. The null hypothesis, H0, is all group means are equal. With a p-value of 0.0604, which is slightly above the 0.05 significance level, we fail to reject the null hypothesis. This indicates that while no significant difference is detected, the result is close, suggesting a potential weak effect that may be relevant in certain contexts. In a two-way ANOVA, you assess the main effects of two factors and their interaction, each yielding its own p-value. If any p-value is below 0.05, you reject the corresponding null hypothesis, indicating significance. Here are the findings. For supplement, p-value is 0.00894, significant effect on the response variable. For dosage, p-value is extremely small, indicating a strong effect on the response variable. For interaction, p-value is 0.024631, significant, suggesting the effect of dosage varies by supplement type. Significance codes indicate the statistical significance of ANOVA results, aiding in the quick interpretation of p-values for factors or interactions tested. The type of supplement significantly affects the response variable, while dosage has an even more pronounced impact with an extremely low p-value. Additionally, a significant interaction between the two factors shows that the effect of dosage on the response depends on the type of supplement used. For one-way ANOVA, check if group means are significantly different. For two-way ANOVA, assess main effects and interactions. Use R's built-in datasets to practice interpreting ANOVA outputs.